4G LTE networks are now well established, both in terms of the handsets available and also the infrastructure. Now the eyes of the mobile telecommunications industry are turning towards the next generation of technology, 5G. Although the first deployments are many years away, much work needs to be done to prepare. So why is 5G needed?
5G is needed because we see growing demands for capacity, but also for capability. Clearly more spectrum will add to the capacity, but some of the capability is very important for high-speed video, for low latency capabilities such as automatic or connected cars.
So although 5G is still very much in its concept stages, what are some of the areas in which 5G could be used?
5G opens up the path to a new category of connected devices. But let me sort of go back and explain what those categories of devices are, because not everything actually needs the power that 5G will bring. If you're talking about a connected sensor, like you might have as a smart meter, or is my parking space empty, or what temperature is my house or something, actually LTE can do that. And there's a new variant of LTE being developed called LTE-M, which is targeting making the cell sizes much bigger and also enabling battery-powered connected devices to still be transmitting small amounts of data every couple of hours, but having a battery life, 2 AA batteries, working for 10 years without being touched. And that's one simple category. Huge volumes of information in small packets doesn't really need 5G. There's a second category of things that we're looking at, which is the ones that will absorb huge amounts of data, and 5G probably plays into that capacity, providing that. And that would be something like a smart TV. You have a 4K screen now, 8K screen, 16K screen, whatever in the future. Huge volumes of data, not necessarily latency critical, but it's going to be for the volume. And then there's a third category, a new one being opened up by 5G, where ultra-short latency and big volumes of data are absolutely critical. And that would be for something like autonomous driving connected cars. It could be something with haptic feedback, like you could imagine industrial automation, or even a doctor using a robot to perform an operation remotely. And clearly in that sort of circumstance, you need absolute ultra-short latency in the network, millisecond or less, as well as huge volumes of data to do it. And it's those new categories that will really be the driver for 5G in the IoT world.
So what are some of the key technologies that will be needed for 5G?
Key enabling technologies is to look at the radio access. So we need a new air interface, and we need a new radio access network, RAN architecture, as well as the core platform that would integrate efficiently broadband and narrowband services like Internet of Things or machine-type communication. And it has to be as flat architecture as possible with full IP and with a resource orchestration mechanism using software-defined networking and network function virtualization.
So what are some of the headline technologies that are being investigated?
So within 5G research, we're looking at some of the key technologies that will really enable that next generation of communications technology. These include truly heterogeneous networks and integration of cellular with evolved new waveforms and Wi-Fi, techniques such as virtualized RAN, full network virtualization, software-defined networks, massive MIMO, new millimeter wave bands, and technologies as advanced as full duplex radio operation.
So is 5G fully defined yet?
5G is quite a complex topic at the moment. There's a lot of different opinions about what 5G is and what it will be. And there's probably two tracks. There's one which is an evolution of 4G, and from that perspective it's a lot about industry sustainability, reduction of total cost of ownership, enablement of Internet of Things. There's also a radical new radio interface needed to promote some of the things around 5G to do with step change in bandwidth and reduction in latency.
And is the way ahead for 5G fully defined, or are there questions still to be answered?
My concern on a lot of what we're hearing is people are approaching 5G as though it were a technology problem about how do we do more of the same, only better. And I think that's fundamentally misconstruing things. I think if we follow that path, we are setting ourselves up for a stunningly expensive, misguided venture. What we need to be thinking about is what are the problems we have to solve, and how can we come up with an architecture or a framework that will solve those collection of many different problems, each with their own solution, but integrated into a coherent, sensible way.
So bearing this in mind, but looking to the future and assuming things will all move ahead, what are the timescales likely to be?
The standardisation process has started for 5G, particularly if we look in areas like the ITU that have brought discussion groups together, or some of the work done in the NGMN work or the 5GPP work. Sorry for all the acronyms. However, that still needs to go into practical standardisation work such as ETSI, 3GPP or IEEE. Because the research is not yet complete, it will take some time before standards are complete, but I think it will lead towards very robust architectures for the latter part of this decade.
So 5G is still in development, and there's a lot of work to do to develop and define it. But it is expected to be available by about 2020, and then in use until about 2040.